Hi, everyone. Thank you for joining us today for building Git Hooks in the Reactor Code Lab. This is part of a weekly series here on our Microsoft Developer Twitch channel and Reactor YouTube channel. We are here every Tuesday at 4 p.m. PT. Sam will be here giving this session. Before I bring Sam on, I do have a few quick things to go over. Please take a second to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactors to be a place everyone feels welcome. Please ask questions using the live YouTube and Twitch chat. In the chat, I'll be sharing some links that go along with today's content, as well as our Reactor meetup pages, if you're interested in checking out what other sessions we have coming up. Also, today's session is being recorded and will be added to the Reactor YouTube page in 24 to 48 hours. And then finally, near the end, I'll be sharing a link to our survey. If you have a few minutes, we greatly appreciate your feedback. And Sam, I will now pass it over to you.
Awesome. Hello, everybody. I am Sam Wronski. I am the Regional Cloud Advocate here at Microsoft, trying to help empower all of you to build and succeed with technology and Microsoft technologies. So what we're going to be taking a look at in this show today is Git Hooks. So Git Hooks are a way for you to tie into things. So what we're trying to do is kind of every week explore different things that can kind of either get announced or are interesting, or in this case, can just improve your developer workflow and kind of improve the tooling and experience you have as a developer when you're building software. So this is going to work for any project that you have in Git. And it's a pretty powerful way to kind of enhance and do what you're trying to do a little bit nicer. So on screen now, I have my project. This is a really quick test project. There's not too much here. That's sort of by design. We're just going to be walking through and kind of walking through a Learn module to kind of explore how these Git hooks work and how you can implement them and how all of that is a thing that you can do. So that's sort of where we're going, is we're trying to implement Git hooks into this little project here. So we just have two tests. This is just a .NET project with two tests in it. One of them just asserts that a string is equal to the same string. The other one does the same thing, but it's a little bit slower. And we can get rid of that little experiment. And then it's also labeled with a trait for slow. So this is a test that is a little bit slow because it waits for 5 seconds. This is sort of intended to simulate one of those longer running, maybe end-to-end tests that you have in your environment. But I thought it would be easier if we started with a project that was this and fit on a single page, rather than something really big that we had to spend more time on and explore a little bit more in more depth. So this is sort of where we're at. It's not even a Git project at this point, so we can get started right from scratch and just git init. And now we have a Git project, and everything turns green and it's all great. So let's check this in. I need a git ignore because we don't want our bin or object in there. There we go. Get rid of those. And so we just have a really basic project. There's a few different things in here that we're going to kind of be playing around with. So let's just commit this initial project and say add initial project. So I have added a little bit of linting here. As unsaved changes, that should be fine. Cool. So we get everything committed where we're in Git. What Git does is store everything in a .git folder for you, but we can't see that. Visual Studio Code is going to show you all your files over here, but some of them are hidden in your configuration. So the first thing we're going to do, just to kind of get started, so we can kind of start exploring this a little bit, is press the correct hotkey. There we go, and open up our preferences. So these are all my preferences. There's a whole bunch here. You can change this as much as you like, but we're going to actually be changing something called files.exclude. So if you go files.exclude here, and swap this in. This is going to allow you to specify specific files that should or should not be excluded from Visual Studio Code. By default, your Git directories are. So I'm going to turn that off. So we're just going to do for any directory, select .git and make that false. So we are not going to exclude our Git things. And you'll notice immediately a directory pops up over on the left-hand side here. So we can now browse all of our Git stuff. And there's already hooks here defined. Your Git project has these already defined in it. So it already exists. So that's, I think, one of the coolest things. There we go. So what this does is let us explore Git in a little bit nicer way. You can do this from your terminal. It's just a hidden directory. But it makes it a little bit nicer for you to kind of get into Git stuff and then start exploring it. Now let's actually walk through this because I'm still learning Git hooks. That's sort of like the premise of this entire thing is we're going to kind of walk through some of these things together and hopefully learn some things. So I have used Git hooks in the past, and I'm very familiar with like GitHub Actions, which is more on the server side. But in this case, we're going to kind of walk through because this module goes into a little bit more. If you're curious, I have a link to it. Here we go. Explore Git hooks, aka.ms/explore Git hooks is going to send you to this module so you can actually explore that and kind of follow through. We're going to cover most of it, but we are going to skip over a few parts because we're embedding this into our existing project. So we're going to be coming at it slightly different. One of the cool things with this is your workflow is different than my workflow. And it's different than maybe your coworker's workflow. The cool thing with this is it's client side. So if you're changing things, if you're modifying things, if you want to explore and add these checks on your side before maybe sharing it with people, you can do that and it's fairly transparent. Nobody else is going to see this. So it's kind of a nice thing. So let's get introduced to Git hooks. So Git hooks are a mechanism that allows code to be run before or after certain Git lifecycle events. So this is a really cool thing. Basically, when you run Git commit or Git push or Git pull, any of those are Git events that you can tie into and run scripts. So maybe you want to make sure you're not checking in those API keys into your commits. It's a lot easier to notice that on the client side before you ever commit any code at all than it is after you've committed and some Git hook has started saying, hey, this is bad. Also, we need to rotate our keys now. So this can kind of help detect those things. You start embedding passwords or bad things. Or maybe checking in code and then you get a PR review that says, hey, this is great, but your formatting is completely wrong. So maybe fix that and then we can merge this. Those aren't very fun to get feedback on because like it's like a one-line change is a small thing. And it's kind of burning a bunch of people's time because now you have people reviewing grammar basically. And that's less fun. Or committing something that the tests don't pass on. So that's what the two things we're going to be taking a look at here is trying to write something that can detect formatting issues in our code. So make sure our semicolons or stuff are all correctly formatted and also make sure our tests are passing. Those are sort of the two things that I want to make sure that if I'm committing code to this repo, these pass, and then we can move on. And again, we're going to be looking at pre-commits, which happen before you ever commit any code, which means before your commit is even created, when you click that commit button, it's going to run these scripts to check that your commit passes these things. And if it doesn't, no commit is going to be created. You're going to get errors instead. So that can be a whole fun way to kind of get used to these things. There's a whole bunch of things here that you can kind of tie into. I was talking about pre-commits. There we go. So pre-commit happens before your commit. There's also post-commits. So after you've committed to something, what do you want it to do? Do you want to trigger some job or something that says, hey, I checked this in, maybe build a release or something like that. And a bunch of other ones. These are kind of up to you. There's a bunch of templates that come when you create a new Git repo. you can just check out what's already there, or you can experiment. It's just scripts. So that's sort of that. But there's a list here of all the different things you have. You can also check your Git repo. And then practical uses, enforcing preconditions. So if you have something that needs to be true when you are committing code, you can throw this into a pre-commit and make sure that that's happening. The most useful thing that I found with these is preventing you from committing code and then having to go back and rewrite Git history because you had these like small changes that now don't really line up with anything. It saves you that work of having to do all of that extra stuff. Another suggestion here is sending notifications to a Teams room. So you can send it to your Teams chat. This might be useful, maybe definitely not on a pre-commit, but maybe some other way, maybe I don't know. I don't know where that would make sense. There could be a post commit that makes sense for that because you don't have to do this on every single one. I'm talking about this. I want every single commit to pass tests. That isn't necessarily how we have to implement this. We could say every commit that has been tagged, for example. We can be a little bit more specific and look at things with a little bit more granularity if we want to actually control how all of this is happening. So yeah, there's that. The other suggestion they have is preventing you from committing faulty code. So code that doesn't pass tests. The one thing that we're going to cover in a bit, the reason there's a really long running test is because if you run every test during your pre-commit, that can get kind of annoying. Because it's going to wait to commit before it has to complete everything. If you have tests that take 30 minutes, that means people are going to be sitting for 30 minutes to commit their code, not even to get it to somebody else, but just to commit it. And that might not be something you want. It might even encourage people to just skip this entirely and find ways around it. And there are ways around it. So things like that are options you have. So where to start? Let's start by exploring client-side Git hooks. We've already explored our Git repos hooks directory. That's all of our samples. So we have everything there. You'll need to find a bunch of samples, but they're disabled by default. So all of those sample commit hooks aren't running. They're just there to give you a little bit of a guide, to give you some examples of things that you could run if you wanted to. To enable it, we need to remove that sample extension in order to actually get these things running. So make the script executable is how this is going to work. If you're on Linux, that may be something you have to manually chmod to do that. So chmod plus X to get that running. And then it should just work. If they're there, it should run. And then all you need to do is just make sure they match the hook that you're tying into. So it's like a one-to-one mapping between the hooks that you have and what you're trying to connect to, the event that you're trying to hook off of. Then the next important thing, if things exit with a non-zero exit code, so some sort of error, it is going to cause the commit or whatever else to fail. So again, if you want to stop something, if your tests fail, exit with a non-zero exit code. Tests, I believe, do this by default. So if you exit with a non-zero exit code, it should just fail your script. And then your commit won't even happen. You'll get the error logs, hopefully, and it should do that. So that's sort of where we're going. The other thing, it can get a little bit weird on Windows. This is not something that I've been exploring, but we're going to dive into it today and see how this goes. This does work in WSL as well. So we will show that. But that's what we're going to be exploring. Obviously, on Windows, bin/sh isn't even a directory. So you might run into some issues there if you're trying to source your scripts and give them a shebang. That's how you pronounce that. Yeah. Oh, I guess let's talk about that. The shebang, is that the right word? I don't know. I've never really say it. I just type it. but the pound and then the exclamation mark is saying run this script with this code, with this program. So in this case, if this extension is going to say run this with our shell program. If you want to run it with bash, you'd replace that with bash, or something else if you wanted to run some other thing. So that's that. Windows is in a Unix OS. Cool. I think by default, we're going to end up in Cygwin, which is installed with Git. So if you install Git for Windows, that comes with Cygwin, which kind of maps a bunch of these Linux binaries into Windows stuff. It compiles them with Windows compatible stuff. So you get access to some of the normal Linuxy bits that you might be familiar with, but they're in just a slightly different location. So you will have to change that to this, which is less nice. It ends up in program files git user bin sh.exe. And then here we go. So this is a pre-commit hook to scan commit for keywords. So in this case, I guess we can just kind of jump into starting to implement these and kind of look at what that actually means. So in this case, pre-commit hook to scan commits for keywords. So why would we want to do this? Why does this matter? In this case, they're checking for passwords. So they're doing a grep and finding passwords. So if you have a specific string or some specific, maybe not a string, but if you have some specific variable names or things that you want to make sure nobody ever commits this, you can catch this way. And because it's a git commit pre-hook, or that's the wrong words. Because it's a pre-commit git hook, there we go. It's going to actually detect it and stop the commit, which means this is never going to end up in your source control. So that's sort of the advantage of this. You probably still, it's not a bulletproof thing. This is literally looking for anything that matches a specific string, which isn't going to catch all that much. But it can be a way to start detecting these and trying to get ahead of them. So there you go. So let's implement this and see how good my my bash is, because it's not very good. So let's jump over here into our, that's the wrong thing. Oh, never mind. It's the right place. Cool. So we want to grab a pre-commit. So let's open up this pre-commit and rename it. So that's just F2 in Visual Studio Code. And we can delete the sample bit. And now we have a pre-commit that is actually going to run when we run it. And so you can see that this is the default test that gets added. It looks like it's removing a few different things. There's also some Git commands that are specific to parsing the current commit. So you can actually look at what is being committed and are you committing things that maybe you don't want to do, or does the commit message include things that it shouldn't include? Things like that. Maybe you want to make sure that every commit message has an emoji in it. You could do that. I don't, that might be a little bit weird, but you could do that. Maybe don't do that, but go ahead and try it. Why not? So anyway, we do not need this. This is just the default sample. So we're going to replace it with the example that we had here. So what this is doing is grabbing our diff index for the head. So this is our current diff. That's the diff of the current commit. Then we're going to, look for the start of files or the start of lines. So that's what this, it's all, grep is all regex. So it's a little bit confusing and you kind of have to know regular expressions. But that's what this is doing, is it's going and grepping, I believe, the start of a file and then anything after that. I believe that might be wrong. And then it's going and grabbing these three keywords and finding those three keywords. If there's any matches, it throws an error. And so that's what's happening there. So let's test this, see what happens. Because I haven't done this. So let's change these tests to password. What happens if I do this? Does it work? I don't know. So we are going to grab our unit test, grab our password, and commit this. And so we're just going to write add password and commit this. And there we go. Words from the blocked list were present in the diff. So we did not commit our file. It failed, and we actually got our error. So we can open our Git log, show the command output, and kind of view this a little bit more. So this is what's happening. You can even see it even included the line that was the problem. So we're getting back feedback that there's problems here. This isn't okay. We can't commit this. If we want, we can force this. So we can skip ahead and just kind of say, don't authorize this, or don't what's the word? Don't authenticate this. Don't make sure that this is actually going to be verified. I believe that is git commit -m add password, because why not? And I think it's no verify is the thing. There we go. And now we commit it. That skips your pre-commits. That just gets past them. So that's one way. If you have something and you're like, okay, I want to save my work. Maybe you want a pre-work or like in process commit, and you want to do that, but it doesn't quite meet like the all tests need to pass criteria. This gives you a way to actually commit past that and get around it. You just need a little bit of like you need to actually say, hey, I actually don't want to run this. So that's that. So that is our first, I guess, Git hook. It gives us a way to kind of detect these. If you're curious where we're getting the error, that's not the right thing. There we go. So error, words from the block list. That's coming from right there. And then it just prints out the matches, which is the result from our grep. So that's where everything's coming from. So now let's do something else. Let's jump back here and start exploring this a little bit more. We don't have to build the complete keyword list in the script, so you can actually add some other things. Oh, so this is actually interesting. It's saying that you could even encrypt or scramble it if you want. So maybe that might be a way to detect like keys or something that you want, is actually match it against a hashed or encrypted version and see if the encrypted parts match. And if they do, it'd work. I am not a security expert though, so I can't say how you would go about implementing that. I don't know. But that seems like an interesting way to do it, is to kind of scan for these things, because that is sort of one thing that you really want to be careful with Git, is committing your source code or your keys, not your source code. That's the point. But committing your keys, those become a problem, because as soon as they're in your Git, you probably just want to reset. You want to swap them over, because it just gets annoying to go in and make sure you actually got rid of everything in history. So, and you can just forget. So giving you ways to like detect that and say, hey, whoa, don't do this, can be helpful. The other important thing is that this is local. This also isn't committed. So this line is kind of highlighting that this is a local thing. So important note, this is not going to end up in your GitHub or wherever else you put your source code. These are a local thing for your computer. So if you want to share these hooks, you will need some other way to do that. What you could do is reference back out to something that is under source control. So have your hook invoke some pre-commit check inside of your code. That should work. Maybe we could even try that, because then you can get your like test stuff to actually be in your script. So you can actually run your tests without having to do a whole bunch of other stuff. But it might be a little bit more. So So as of Git version 2.9, you can map Git hooks to a folder that can be committed to source control. Okay, so what this is doing, each of these Git directories is in your local directory, which means it's going to exist for that project. So in this case, these Git commit hooks are part of this Git project. We can pull them out, and I think we can define something that's like more global. So if you on every project you ever create to run something, I think you could do it this way. But this is not something I'm super familiar with. But this is a Git global setting. So what we could do, let's just do this, and I'll figure out how to undo it later. But we can throw this into some directory. That's the wrong place. There we go. So what we're going to do is git config global configure our hooks path, and I'm going to put it in my other directory somewhere else. Will it accept a directory that doesn't exist? Let's find out. Sure, why not? So there we go. We put that there. Let's open that up just so we can see that. Make sure. And create our Git hooks. There we go. And let's just open that. So if you're unfamiliar with Visual Studio Code, code-n, and then a directory, wherever that directory might be, is going to open up a new directory or a new copy of Visual Studio Code at that location. So this works for a few other programs too. Notably, Explorer also supports this. So if you do code-n, and then the thing you want to open, you're going to get an entirely new editor. You can also do -r, which is going to reuse the existing window that you're running that command in. So if you have a copy of Visual Studio Code open and you want to switch over to a new project, you can do -r to do that. But let's just create this, open this new thing, and there we go. So there's nothing here because we haven't created anything. But let's copy this and see what happens. So if I paste this, does this? Okay, it might get a little bit weird. We're going a little bit off script, so it's cool. There we go. There's our new thing. Let's comment this out again. So let's rename this .sample. Now that doesn't run in this directory. It's a sample, so it's just like all these other samples. It's not going to be included in this. But what happens if we actually try this? So let's do this. I think one of the things is we may have made this project a little bit hard because we committed this password. So anything that changes this line is going to get caught. Because we're checking the diffs, we're not checking the entire file. That means we're not going to scan every file. So even though this password is not something we want, let's say we want to change this from test to hello world. Sure. So just some other string. We should still be able to commit this. And I think it should just pass because the diff will not include this line. That's why that's going to work. But if we ever do, then we'll get the error, even if the change itself isn't specifically adding this password. So that might be something to keep in mind, I think. So let's add this and just do add password again. There we go. So that worked just fine because we just changed this bottom thing. But if I want to do this, let's say we want to comment this out, because we might do that. That probably is going to cause an issue because it's changing that line and it's by line. So if we do this, remove password, interestingly, we won't be able to do this, I don't think. Yeah. So we actually get in trouble for trying to remove this password. So interesting little behavior there. Something that can come when you start forcing these changes through. Is it might break later down the line. This can get a little bit annoying in team projects if you start doing that. Like if it's in your workflow to push things through, your teammates might not appreciate that if they eventually start getting these kind of errors for things that they weren't doing. So cool. there we go. And that is our global commit hook running from the that new directory we just created. So it is no longer part of our project, it's somewhere else. So I think we can, what's the best way to do this? Let's rename this, I guess. Kind of juggling a few different things. So we do .sample, and that will comment this out. And then we can jump back here and change this. Let's rename this. I think this should work as well. Kind of experimenting here because this is actually part of the thing that I'm not very familiar with, is how do these global things interact with the repo specific ones? Do you have both? Do you have one or the other? Don't know. So let's explore. So we have our pre-commit now. Let's change this to something. I guess we were uncommenting that. Oops. So let's do this. We have our password. Let's comment this out again and try to commit this. We should get the same error if the behavior that I'm expecting happens, and we do. We don't. I didn't do what I was supposed to. Let's actually stage this and then commit it. There we go. And now it works. Okay, so because we have that global hook, it is not looking in this directory anymore. So that's something to keep in mind. That's interesting. The cool thing is with this Git Hooks, you can commit that to source control. So you can have a Git Hooks repo that everybody that wants to use these just points at and grabs them. But the advantage of this, or at least one of the things that I really like, is you can kind of tinker with this and implement your own checks that fit your workflow. So if there are things that you do just as your way of working with Git or your tools, you can tie them in together and start actually integrating both of them together, however that fits your workflow. So let's go back here and see where I am. There's the no verify that we just ran a bit previously. That allows you to skip what is actually being run. And so let's skip over to implementing them. So the cool thing with this, when pushing quality into the development process, you might want developers to identify and catch code quality issues. This is sort of the nice thing. One of the things that I really don't really like when as a reviewer, and one of the things that I would encourage other people to do is try to avoid like linter errors and formatting errors being handled in code reviews, because that's actually a really long process if you start thinking about it. Because then you've committed your code, you pushed your code up to your repository, you created a pull request, you've asked for one of your peers' feedback and said, hey, can you take a look at this? And then they found the time to go and look at it and been like, oh, there's a spelling error, or this isn't formatted correctly, or you're missing some white space here. And that entire loop just had to happen, and you had to go and request a bunch of people's feedback for small little errors that can be corrected automatically. So this can actually help you do that and hopefully avoid some of that toil back and forth, especially if you're working in like a global team where you have people across the globe and it might take you a day to get a review. If that entire day's review is just fix white space, that's a day of just waiting for your code to get checked in because you need to fix white space and you need a review. So yeah, fun things. Git Hooks allow you to run custom events. We kind of covered that already. Ship with several custom hooks. Cool. So let's implement our own thing. So we've done all of the normal stuff. If they return a non-zero, that's sort of what we're looking at. It's going to cause issues. So let's start implementing this. So if we scroll down here, this all looks very similar. So never mind. Let's go and do this. So we're just going to open this up and actually kind of play around a little bit with what's here. So we have our pre-commit. These are no longer being used. So let's comment those out and open this. And let's actually start exploring a little bit of what we can actually do. So the two things that I'm really interested in for this are tests and formatting. Luckily, .NET gives us both of those. So we don't need to actually like pull in any extra dependencies for this. It's just there. So if we want to do this, it's a test project. So I can just run these two tests. Let's uncomment that assertion, and we'll just do .NET test. And so what this is going to do is actually go and run our tests. We have a few warnings here. That's fine. I'm going to leave those. But you could theoretically even prevent people from committing warnings. That might cause issues, especially if you're trying to like pull this into an existing project. I can't imagine that that's going to go as smoothly as you might hope. But again, the scripts are up to you. You can implement them however you want. I'd actually be curious, is there anybody in chat who has some use cases that they'd like to see? Like maybe some things that we could explore as we're going about this? Because I've got some ideas, but we can tinker and go off the rails as well. So for now, let's take a look at .NET test. Just ran that, and .NET format. So .NET format is this really cool thing that I don't know if I use as much as I should, but it actually can correct your formatting and find formatting issues in your code and automatically fix them. Plus, it can plug into your third-party support stuff. So you can actually start pulling in these other bits. So if you have extra linters or things like that, you can pull in these other code analyzers to address some of the issues. So let's create some code formatting issues. So we're just gonna make this look real great. There we go. And it compiles, so it's probably fine. So there we go. This is our fantastic code. Hopefully yours doesn't look quite like this, but it's pretty easy to like have those brackets on the wrong line, for example. I do that all the time. So that's a thing that you might want to catch. .NET format is going to find those. So this should all go away. If you just run .NET format, it's going to run over the project and replace all of the things it found. So we just reformatted our entire document. So it's all back, and it doesn't look quite as bad. But what we can also do is insert slightly less formatting issues and just do verify no change. That isn't how that's supposed to work. What? Interesting. Okay. Wrong thing. Verify no changes. Interesting. So fun little stack trace there, but verify no changes is going to actually return errors. If there's no errors. Interesting. Okay. We'll do that. But basically what that does is it runs format and then diffs the two files and sees if there's any changes and reports those in error if there is one. So in this case, we get an error that white space formatting is incorrect. And it has the replacement here, but it's not applied. The file did not change. But what this did do is fail. So we now have a failure for our CLI. So we should be able to actually hook that into our script. And we can actually detect these formatting errors in our pre-commit. So let's do that. So let's just grab this line here and throw it into here. So I'm just going to run this, I think. It should be that easy, I think. We will see. So this is going to just run that same format command, but every time I commit. So if I try to commit something that has these same issues, hopefully we'll see some break formatting. And hopefully we'll get an error that the formatting is incorrect. We will see. Also, an important thing, there we go. So that failed and we got our error message. It reported the standard out back to us. But also, again, this makes your commits take longer. So if we're going to add our .NET test next, Let's just make this really miserable. Let's actually not do that. But it's not uncommon for tests to take a long time, especially if you have end-to-end tests or integration tests that need to spin up infrastructure or do other things, or if you're testing like timeouts, then it's going to take a while. You probably don't want to run those every time you commit something. So we were running .NET test, which is going to run every test. That's probably not what we want because it runs the first test real quick. But that second one is waiting for 5 seconds before it returns. Let's make the code a little bit nicer to read. So what I've done is I've added traits to this. How you want to do this is up to you. But I like to kind of separate out the different things in my tests. So I can have my normal tests, my unit tests that are really quick, just run. But I can also have like longer running tests that don't need to be run as often, but still should run. This is useful if like overnight or something like that, because if you're trying to run these like every time as a developer before you commit anything, it can take a long time. So let's do that. The way you run something like this is you do .NET test, but then you add some sort of filter. So in this case, we're going to say our filter is equal to category is not slow. We're going to run all of our tests that aren't slow. And this will only return one test result, but it's going to go a lot faster. There we go. And so this actually kind of helps, especially when we're talking about automating these things. It's going to make everything a little bit nicer for us and hopefully prevent us from spending a whole bunch of time waiting for these things to kind of come back with results that don't mean that much, or that we already kind of know pass. Because if you have to run these every time, it's going to be a lot. So let's register that as well. And we'll just throw that in there. And so there we go. So now I can actually run these. And so we will skip that. We should have our formatting fixed. I should be able to commit this because our tests pass and we don't have any formatting. If I run .NET format, it should just work. There we go. Hopefully. Cool. So we did have changes. Interesting. Okay. Well, let's unbreak our formatting. Cool. And then we'll commit that. I need to save. Got it. Okay. Weird things happened. That didn't refresh. So let's go and grab that. There we go. Everything's cool. So unbreak our formatting. Perfect. So we should be able to commit this. It should just work because we've got our commits. We have our formatting. It should all just pass. We are still running things because we have to run our tests and we have to run our formatting. So we did extend the time it takes to create a commit. It now takes a few seconds rather than almost instant. So again, be cautious with that and consider what you're trying to accomplish here. Adding too much here can make things kind of not fun because I guess for me, one of the things that makes my code the best is when I can iterate a lot. When you can start testing things and going really fast and trying things and seeing if it works. And for me, that means committing a whole bunch and saving what I'm doing and then switching to a different branch and trying something else and then figuring out which one I like. So that is all that. Our formatting passes, our test pass. But what if we break our tests? So let's change this to password is equal to keyword. Now our tests don't pass anymore. But we're just going to commit this because we're going fast. So we're just going to take our unit test and we're just going to say update test. Now we're just going to commit that. So this won't work, I hope. So this should fail now because we changed this. We have a commit pre-hook. It's going to say don't check this in because this test doesn't pass. Determining projects to restore. Interesting. There's probably a bit more here. There we go. And so we can even get some test output here. So inside of this result, this error that we got, we're getting all of these. If we want to do this from the command line, you can even see a little bit more about what's coming out, I think. I say that I haven't actually tried this, so we're gonna see. Git commit -m. We're going to call this update test. And so this hopefully checks in our new test. There we go. And now you can actually see it's running our tests. So it's actually giving you all the output. And now here is our failure. And so we get our test results directly in our Git shell. I didn't tell it to run the tests. It just ran the tests. And it only ran that one, but it did run tests, and it prevented us from even creating a commit with this failed thing. If I go and look at my, that's not the right thing. One of these is forget. Commits, there we go. If I look at my commits, there's only 5 commits. We've been committing constantly, but we're not creating anything. So I think this is useful. Hopefully it's something that people want to use. But we can take this a little bit further. This is something that I don't actually know how this will work. So we're gonna try. We have about 10-15 minutes left in this session. So if there are things people want to see or suggestions for experiments that we could run, let me know. Otherwise, we're going to take a little peek at doing this all automatically and trying to replace that format because what we have right now fails. But if we run .NET format, that doesn't throw an error if the format needs to be changed. So if I do this again and run .NET format, I believe the error code or the exit code is 0 after this command, which means that we can just ignore it. Yeah, we get a 0 exit code, even though we did some changes. So how does this work? That's sort of my question. Can we just automatically format? That's not what I wanted to do. Can we just automatically run this formatting and not even need to do that? It will just run behind the scenes and make sure everything's good. So even if your formatting isn't correct, if it can correct it, it will. And check it in still. So will that work? This might not be something that you're comfortable with or that you want in your code base, but I'm curious how this works because this would mean you would be able to do some correction or some other stuff as part of these processes. So let's try that. We're just going to replace it with .NET format and see what happens. I also need to fix our test because otherwise it's really not going to work. And let's commit this and see what happens because it should get automatically corrected. But the question is, does it get corrected before or after the commit? So when we create this change, we're going to fire off our pre-hook, our Git hook, and see what happens. I'm not sure I understand that question, Chili Crunch. If you could rephrase it, that'd be great. And then I'm happy to try to help. So let's explore formatting, see what happens. So we have our password updated. It should all be good, but our formatting is wrong. So let's break or fix formatting. So I guess that's what we're doing, right? We're fixing the formatting because it should just automatically get fixed. Our test should pass and everything should be good, but our formatting will need to change. So what's either going to happen is we are going to commit code that we didn't have, or there's going to be a new change in our code. You can see the formatting was already applied. And it looks like we have no change. So it looks like we committed this. Okay, I guess that makes sense, right? Because you're committing your files first. I wonder, there might be a way to do that though, to actually roll that change in. I'm just not entirely sure how. But that might be something that could be fun to kind of roll in. Because then it can automatically do these changes for you. The cool thing is now we have this commit, so I can just roll this in to the next one. maybe there are some hooks that we could take a look at. We have pre-push and pre-rebase. So rebase might be maybe not the best way to do that. But pre-push would be if you're considering pushing this to a repository. So this might actually be where you'd want to run some of those long-running tests. If you're considering pushing up things, you might want to try that. Hello, yes, want Kumar? Welcome. So pre-push might be a good way to put your tests. It might to actually run some of those long-running things. So you before you commit and ask for a PR or something, you can run all your tests and just make sure it's good, because typically pushing is what happens right before you actually ask for a review. So this could be a useful place to put that. So if we want to do that, let's just do it. Let's create a pre-push. So let's do a new file, pre-push. And so we're just gonna copy what we did here and run through it again. So instead of that, I don't need to do a format because we already have the format check. That's already there. But we do want to run all of our tests. I also don't have this actually with a remote repository. So I'm realizing right now that we don't have a way to test this really quickly. So, oops. But that's an option. What else is a good thing? Commit message. What does this do? So one of the things I'm noticing is there's actually documentation here, which probably shouldn't have just been going through and deleting it. But you actually get some documentation here, it looks like, of what this actually means, what these hooks are for. So an example hook to check the commit log message. So if you wanted to check when the commit log is updated, the name of the file that has the commit message. Oh, this is interesting. So it actually passes in a file with the commit message. So if we were talking about that thing where you required an emoji in every one of your commit messages, this could actually be a way to solve that, because this would give you the commit messages. So you'd actually be able to see what was coming through. So let's see what happens. Let's grab this. It's just commit message, I think, is the hook. And let's add that. So we have our pre-push, we have our pre-commit. We want commit message. That didn't work. All right. And then let's actually, so this is saying that we're going to get a argument here. So if I remember my bash/shell scripting, we should be able to cat that out, I think. Oh, this is this is not my place of expertise. So this is typically where I would head off to Bing/Google/whatever search engine you prefer, and figure out how to do this. But we're just going to write some code and see what happens. Now we're going to write a commit and see what happens. Because that seems like a better way to test this. In this case, it's a local repo, so there shouldn't be any like big concerns. And the entire basis of this project is just creating a .NET new test project. So we're just working from a test project because it gives us a way to run our tests, to do some of the other things. Other fun things that you have here is you could run Markdown Analysis. So you could actually check that your docs don't have dead links, for example. If you're updating Markdown files, you may not want to commit links that don't actually go anywhere. So this could give you a way to do that. So why did nothing change? Commit hooks, that's why. So what's in our file? Let's try this. Commit git commit add formatting. Sure. And we should see a few things come up here, because we're going to now trigger, I think, 2 different things. So we should see something that says formatting, if I got this correct. It looks like we are running our pre-commit first, and then trying to cat out the wrong thing. Oops, that's my bad. But it did work, and I did get the thing right too. Neat. It's just in a slightly different place. So here is our tests from our pre-commit. And then after the pre-commit runs, we get a commit message update right here, which is running my cat file. But I clearly did not write that command correctly. So oops, that's on me. But that's an option. You can actually use that to scan the commit message. Is that even just hanging around? There it is. So that's the file. Just slightly off on the formatting there, but there's our file. That's what we would have been able to open up and browse and gotten a message from that. So we could have actually inspected our commit message. So yeah, are there any quick questions? We're kind of wrapping it up, running out of time. I know there's a few of you in chat, and I really appreciated you all chatting. But yeah, if there's anything else you want to see, or we run this series every Tuesday. Today is Tuesday at 4 p.m. Pacific time. So if you want to suggest things, or you have things that you would like to see, maybe new technologies that you're curious about, or other things, maybe some other design stuff, or other ways we could use this, let me know. Feel free to reach out and make some suggestions, and we can take a look. But other than that, I think I got it all. I got your name right. That's good. Perfect. Yeah. Other than that, I believe there is a few links in the chat. If you're curious, you can go and grab those. Those will give you the walkthrough. There are two. So one of them is what we were walking through today, which is the Explore Git Hooks link. So aka.ms/explore Git Hooks. That's going to walk you through the Git Hooks part of this. But this is actually part of a larger learning module over here about learning GitHub for enterprise. So if you're interested in like applying cool Git tricks to what you're doing in your job, there's an entire series on this, and we went through one of them. So if you're curious about learning more about Git, hopefully this gets you a little bit inspired, and you can follow that link to go and check them out. So yeah, I think that's it though. So thanks everybody for watching, and I will see you next week right here at 4 p.m. Pacific. So thanks.